Hey guys! For my major project for the class, I did a cost analysis of microalgal biofuels. So the main questions that I'm getting at is what is it? What is the process for making them? Is there any legislation out there? Is it viable? What's the cost? And why are people interested? So here I have a little graphic on the microalgal biofuel process. So as you can see on the left, carbon dioxide, nutrients, and sunlight go in because these microalgae use photosynthesis to produce oxygen and lipids, and more on that later though. So carbon dioxide, nutrients, and sunlight go in. The algae is grown, then it is harvested, it is dewatered, and then it can go either two ways. So the oil can be extracted and the oil can be converted into biodiesel, or it is fermented and the algae is converted to bioethanol. Here I have another graphic kind of detailing the process for growing and harvesting and refining microalgae. So for the algal culture, there are many different species of microalgae that people use, that scientists have been using. They've been using different ones, kind of fiddling around with different kinds to see what works the best, and it's in the early stages of production at the moment. So, um, so it's grown first with all the nutrients and sunlight and water that I mentioned before in the previous slide. And it is grown in either a pond, a photobioreactor, or a fermenter. More on that later. For processing, there are many different kinds that have pros and cons that I'll be speaking about later. But there are different kinds of harvesting, like flocculation, either chemical or electric, and clarification, flotation or sedimentation, filtration, and centrifugation. Excuse me. Okay, and then it goes into cell lysing, which fixes mechanical damage, sonification, electrodistension, depressurization, and CO2 extraction. And then it can go either to biomass or to biocrude, which is the lipids, via separations, so solvent extraction, centrifugation, and enhanced coalescence. And either those two ways, either from biomass, it can go into fuels, chemicals, or protein, or the biocrude and the lipids can be turned into biodiesel. These refining methods include transesterification and post-processing. So getting more into harvesting techniques, I have a table from an article by Sin and Patidar that delineates different disadvantages and advantages of different algae harvesting techniques. In their article, Microalgae Harvesting Techniques, a Review. So they mention coagulation slash flocculation, flotation, electrical based processes, filtration, and centrifugation. So for coagulation slash flocculation, these chemicals called flocculants are used to neutralize the negative charge on microalgae, which enables agglomeration. So the pros of this is that it is easy and fast. It is good for large-scale harvesting. It can be applied to many different species, and less energy is required than other forms of harvesting. Some cons include that the flocculant chemicals themselves can get expensive. They're hard to separate the coagulant from the harvested biomass, and the culture medium recycling is limited. So for flotation, it is a gravity separation process in which air or gas bubbles are used to carry the suspended matter to the top of a liquid surface where they can be collected by the skimming process, which is very easy to imagine, whereas some of these other processes may not be as intuitive. So it is suitable for large-scale projects. It has low space and low cost requirement, and it has a short operation time. A few cons include that it's expensive and it needs surfactants. So for electrical-based processes, it uses electrodes to separate out sediment. So to separate the water in microalgae, and also these other contaminants can get into the mix depending on the method that was used to grow it. So the pros for electrical-based processes is there are no chemicals required and is applicable to all species of microalgae. Cons include metal electrodes are required and high equipment and energy costs are involved. So for filtration, under filtration, algae culture is allowed to pass through filters operating under gravity, pressure, or vacuum force to hold back algae in a thick paste form. So for this harvesting method, the pros include that it has a high recovery efficiency, it's cost effective, no chemicals are required, and there's low energy consumption, which is good, and the water can be recycled, which with some of these other methods, that is not the case. Cons include that it's a slow process and it's not suitable for small algae. So lastly, we have centrifugation. It's an expansion of gravity sedimentation where centrifugal force replaces gravity for separating microalgae from their growth medium. If y'all have had like biology in high school, for example, or I guess lab in college, they have this, it spins centrifugal force where it goes in a circle, right? So it spins it so that the sediment gets separated. So pros include that it's fast and effective. It's preferred on a small scale, has a high recovery efficiency of more than 90, and it's applicable to all types of microalgae. Cons include that it's expensive with high energy required, has high maintenance and operation costs, and it is time consuming and not viable on a large scale. So why are people interested in microalgae? One, it's CO2 neutral because while it's growing, does take in carbon dioxide and releases oxygen, the opposite is happening whenever you burn it for energy, right? So people say it's CO2 neutral. Microalgae themselves are high in lipid content, more so than soybeans, which is a high lipid producing crop. It can be used in pharmaceuticals. It can be used in the food industry, like health foods. You've heard of spirulina, which has health benefits. Also in the animal feed industry. So it can be used to feed cattle and the like. Wastewater can be used, which is a big plus because you don't have to filter out the water first, so that saves a lot of time and money, and less land. You can use less land than other terrestrial crops used for biofuels. Also, with the food versus fuel debate that we've been talking about in class, it does not compete with that, right? So you're not growing microalgae to eat it. I mean, you can, but it's not a major staple crop.